Combining like terms is our next section. It's EE1B. And the first thing we need to look at is some vocabulary terms that you're going to hear us saying in class and you're going to see on tests. So the first one is coefficient. And the coefficient is the number in front of a variable. So, for instance, in 3x squared, the 3 is the coefficient. It's in front of that variable. And that goes for anything. I could say 8y, and 8 is the coefficient. It's in front of the variable. Constant terms is the next vocabulary word. Constant terms are numbers by themselves, meaning there's no variable next to it. So examples would be 10 is a constant term, -3 is a constant term. Those are constant terms. There's no variable there that's going to change it. If constant means it's never changing, 10 is never going to change. There's no variable or unknown number next to it that's going to change its value. It's not like 10 times 3. Then it would be changed to 30 if x was something. And the last vocabulary term is like terms. Like terms, and this is the important definition, it's what this whole section's about, is that they have the same variable and the same, same power. And we're going to talk about examples of what that means. But remember, powers are like exponents. So we're looking at the exponents in the problems to see that they're the same. Some examples of like terms. So the first example that we gave you is 2x and 4x. They have the same variable, x, and they're both to the first power, meaning x to the first power. It doesn't matter that 2 and 4 are different. We're only looking at the variables and the exponent with that variable. Not like terms would be 2x and 4. 2x, there's an x, 4, there's not. So those are not like terms. Another example of like terms would be if I had -10 and 6. Those are like terms because they're both constants, meaning neither of them have variables. You've always been able to add -10 plus 6. That hasn't changed. So if there's no variable for either of them, they still are like terms. Not like terms, that would be if I had, 2x squared and 3x. These are not like terms. They don't match. Yes, they both have x, but this one has a power of 2, and this one has a power of 1. So because of these being different, they are not like terms. Another example of like terms would be if I had 6xy with -4xy. These are like terms because they both have x and y together. Whereas not like terms would be if I had -14x and 3y. These are not like terms because this has x and this has y. They have to be the same variable. Identifying like terms. So here's 2 examples. Identify all the terms that are like 2y squared. Hit pause now and see if you can write down the ones that are like terms to 2y squared. Okay, the answer is 18y squared and negative 4y squared. They are like terms because all three of them have the variable y, and they're all y to the second power. The other ones have x, so that makes them not like, and 9 is a constant term. It doesn't have any variables, so it doesn't match that one. Try the second one. Identify all terms that are like 14x squared y. The answers are 9x squared y and 10x squared y. Again, all three of them have an x squared and a y. The first one doesn't work because it has just xy, but there's no exponent with the x. The second one doesn't work because the squared is with the y and not the x. And negative 8 is a constant, so that doesn't work either. Now let's look at a couple examples. Remember here at the bottom it says the operation before a given term goes with that number. Meaning if we look at the first example, 3g plus 7 plus 8g minus 2, where it says minus 2, that's really a negative 2. So how do we show that? We do add the opposite, so we can see that it's a negative 2. Now we can do like terms, and I always recommend you use some shapes to show what matches. So 3g matches 8g, and 7, because it's a constant, matches the negative 2, and make sure you include the negative when you're putting a square around it, or any shape. Now because they have the same shapes, I know which ones need to be added, and everything is addition in the problem. So first I'm going to do the 3g plus 8g, and that gives me 11g. Since everything's addition, I know there's going to be another addition sign there. And now I can add 7 plus negative 2. 7 plus negative 2, they're opposite signs, so I subtract 7, 6, 5. And because 7's bigger and it's positive, 5 is positive. And that's my answer, 11g plus 5. Let's try the next example. Negative 8v minus 9 plus 2v plus 10. Again, there's one subtraction sign, so I am going to add the opposite, so I remember that's a negative 9. And then I'm going to circle, I see, negative 8v matches 2v, and negative 9 matches 10. So negative 8 plus 2, opposite sign, so I subtract in my head. 8 minus 2 is 6, but because the 8 is negative and it's the bigger number, it's negative 6 plus, and then negative 9 plus 10, opposite sign, subtract 10 minus 9, you get 1, and the 10 is bigger, so it's positive 1. My answer is negative 6v plus 1. Couple more examples. I'd like you to try these on your own. Let's see, try these. And then check in with me. When you're done with both of them, I will tell you if you're doing them right or wrong and help you out along the way. Good luck!